Hello, can you hear me that side?
Yes, I can hear you.
Hello,
Yes, I can hear you.
am I audible? So that we are on the same page. Hello,
Hello.
yebo, yebo. Yeah, if you
Yes,
are,
I can hear you.
all right. If there is a question, you just unmute your mic. So we'll continue with the trigonometric integrals today.
All right, no problem.
Yes, so let's see how it goes. The others want to join, so let me just check.
Okay.
All right, I was waiting for the fourth guy to join, but it seems that he's not joining. We can continue. All right, I will share the screen. I was just waiting for the other person to join. However, let's do examples on trig substitution. The recording on partial fractions, which we did, it's there. It's on that it's not yet uploaded. I will share the link via YouTube since the share point of the Vula email is giving a problem. So that is what I'm doing now. It's uploading as we are speaking now. It's ready by the morning. I will share the link. Okay, let's continue. If the screen is not clear, let me know. If you are not seeing anything, just let me know. Otherwise, if you keep quiet, I won't know. All right, let's continue. So suppose we are given to evaluate the integral. Suppose we are supposed to evaluate the integral. The question is telling us to evaluate the integral I is equals to the integral of dx over x squared root of x squared plus 4. Because this is what we are given. So whenever you see something under the root sign, then you know that you are going to use trig substitution, or the question automatically tells you that use trig substitution to solve this. If the question does not tell you what to do, then whenever you notice a square root under on the numerator or on the denominator and notice a square root, you can try trig substitution. Evaluate using trig substitution. So we are going to you must have an assumption here, which you must let if you are given a certain situation. For the previous one, we're doing the one for tan. So here you can see that they are adding the denominator, so which means that your assumption is square root of e squared x squared plus a squared. So you can see that the denominator is in that form. So which means you are supposed to find what is a, what is b, what is c. So you have picked out that you can relate the denominator to this function that we are having there. So you have picked out that you can relate this function, which is the denominator, you can relate it to this. So which means the trig substitution that you are going to have, it must be related to this. So that is the first step that you must first do, is to identify. The first step will be to identify that. All right. So once you have identified, now we need to let. What are we going to let here? So if you are given that situation, there are 3 types of situation whereby some of it here is going to be a negative. Here is a negative, then already what you are going to let is going to be different. And the other one is whereby a squared is subtracting the other one, or it's bx squared subtracting a squared. Then the situation changes for what you are going to let. So in our case here, we are going to let what? We are going to let x equals to a over b tan theta. So this, you must know them by heart. What you are doing, you must know it by heart, that if you are given that situation, let, which means you are going to let x equals to a over b tan theta. For that situation which you are having, a over b tan theta. So whenever you are given this situation, which means you must be in a position to pick out that if I'm given that situation, first you identify, is a squared added to bx squared, b squared, x squared, or is it subtracting? If it's subtracting, then it can either be secant theta or sin theta. But for addition, you must just know it's tan theta. Addition, x is equals to a over b tan theta. So from there, now we are now going to substitute our values. See, we change the variables of x into the variables of theta. That's where we are going now. Everything in the x must be changed into theta. So we are changing the variable from x into theta. So everything that is here in terms of x, dx, it must vanish, x must vanish, we put it to theta. Then we bring it back again. All right. So a over b tan theta. All right. Now, if that is our situation, then let's have our values, which we are going to put for them, which means we are having the denominator is x squared plus b, x squared plus 4. So if the denominator is x squared plus 4, let's write it. So which means the square root of x squared plus 4. We want to put it in this fashion, which means it's equals to the square root of b x squared plus a squared. That is our format. So we want to know what is b, what is a, so that we can replace on our what we are going to let you. So on our situation, you can see that bx squared, the coefficient here is 1. The coefficient there is 1. So which means we are having a 1 here. Here there is a 1. But you don't normally write 1 times. So in other words, your b already you know that b is equals to 1. Then also 4 is equals to a squared. So which means in other words, your a is equals to the square root of 4, which is what? Which is 2. So now we have found our values. So instead of writing this, let x be equals to a over b tan theta, now you let your x, you know the values now. Your a is 1, your a is 2, your b is 1 tan theta. In other words, like this. X equals to a, which is 2, over b, which is 1 tan theta. Like that. In other words, you can be in a position to draw the triangle. Now, you are in a position to draw the triangle. By that, what do we mean? You can draw the triangle like that. Then we put our right angle. Tan theta, it means opposite over adjacent. It is opposite. So we want to know what is tan theta equals to, because that is x. So for tan theta, now we can solve for tan theta is equals to what? Let's go tan theta is equals to x over 2 from that. So if tan theta is equals to x over 2, which means that your opposite over adjacent. So your opposite here is x. Then the adjacent is 2, like that. Then the hypotenuse, that is the one that will be root of. It will be root of what? Root of x squared plus 2 squared, which is what was under the square root. So what was under the square root was x squared plus 4. This is what was under the root. So first, this is the information that we have acquired so far. That's the information that we have acquired so far. Okay, so let's just have a recap of what we started. We started from here. We want to find the integral. We equate the base, the denominator, in relation to trigonometric substitution. So if b squared, x squared, b squared, x squared plus a squared are adding, which means if there's a plus there, it's a must that you must let x equals to a over b tan theta. If you make another substitution, it will not work, or it will take long for you to arrive at the answer. So after that, now we want to know from here, what are the values of A and B when we compare? While we are comparing there, we can see that our A is 2 and B is 1. Then we substitute in the formula. Then we draw the triangle. So that's where we are now. So from there, you must indicate the position of theta. That theta, that is our theta. That we are certain which theta are we talking about. Okay. Then from there, now we want to substitute everything that is in the form of x, it must go to dx. So now it's a matter of now substituting. So which means we are having our equation, which we have left, which means x is equals to A over B. Our A was 2 over B 1, which means just 2 times theta. Our x is equals to 2 times theta. So we come and say, what is dx with it? We want to differentiate this with respect to theta. Then the answer is equals to 2. When we differentiate tan, we are going to get what? Secant squared theta. Now, once you are here, then you want to say, so what is dx? So that you can replace dx in terms of theta, which means I'm applying by d theta both sides. So which means your dx, which you are going to replace, is the same as 2 secant squared theta d theta. So you replace it with theta like that. Now we know dx. So what is left? We need to replace other variables. It's not only dx, we have replaced it. Now we need is x squared. And what is that root in terms of theta? So we have to also find the value of x squared in terms of theta. What is x squared in terms of theta? So that we replace everything. X squared in terms of theta. Right. So let's move on. So dx, we have it now. Now we want to know what is x squared in terms of theta. So we come and write that our x equals to 2 times theta, which implies that x squared is equals to 2 squared, which is 4, tan squared theta. So where there is x, we are going to replace with that. X squared. We will replace x squared with that. Where there is dx, we are going to replace dx with that. So that is our trig substitution which we are talking about. So where there is dx, we replace dx with that. Then that's what we are going to replace. Where there is x squared, for x squared, we are going to replace x squared with that. Replace x squared with that. And what's left is the root of x squared. The root of x squared. What are we going to replace the root of x squared with? So our due, it says that for us, our rule says that if you let this equals to x, when you let this equals to 8, what is it that you are trying to get? You are trying to get a, which means you are trying to get a root of. So this is what we are going to try to get. So we are going to try to get a second bit. That is what we are trying to get. So which means what is under the root sign is now a second bit. So our a, we already calculated a was equals to 2. A is equals to 2. B is equals to 1. So what we are going to get there is a second bit. So which means the square root of x squared plus 2 will be equals to a second bit. That is what we are talking about. That is the value which you want to get for the root of x squared plus 4. The root of x squared plus 4 is to be equivalent to a second squared bit, which is 2 second bit. So that you must know it by heart. Right. So that here we come, we write our value, that for everything that is going to be given in terms of root of x squared plus 4, it will be replaced by, it will be equals to a, which means our a is 2 second bit. So we already have our substitution that we are going to be using. So for that, we are going to replace that. So it's a matter of now finding out what is I equal to. So from there, we're going to replace. Where there is I, just I, right, our I is equals to the integral. Where there's dx, instead of me putting dx, now I'm putting 2 second squared theta d theta. That's what I'm going to put there. Now I'll put 2 second squared theta But sorry, the network had kicked me out. So apologies for that. Let's continue. I'll share the screen. Right. All right. So that's where we are now. So what we are saying there is that Now we need to check any common between the numerator and the denominator. So we can see that secant is common. So we can see that secant is common. This is common from the numerator, and it's also common on the denominator. It's also common on the denominator. So it's a common factor. So we can factorize, or they can cancel such a way that we'll be left with, we are left with now the integral, which means it's now equals to the integral of, we cancel, then we'll be left with, so the 2 and the 2, they cancel, then we are going to be left with what? On the numerator and on the denominator. So which means it's going to be secant theta over secant theta over 4 tan squared over 4 tan squared theta d theta. Theta d theta. You can put it on the numerator if you want, you can put it outside. Fine. D theta. So that's what we are having. You can put out the integral, the quarter, you can put it outside of the integral, which is equals to 1 over 4. Outside the integral is 1 over 4 integral of what? 1 over 4 integral of secant theta is secant theta over 4 over tan squared theta. Over tan squared theta is like that. Over tan squared theta dt. Then from there, we want to know what is secant squared theta, what is tan squared theta. Okay. So do the manipulation of secant squared theta and tan squared theta. Come and say is equals to 1 over 4 integral. Okay. 1 over 4 integral. Secant theta is 1 over cos. Secant theta is 1 over cos theta. So secant theta, where there is secant theta, we are going to say 1 over cos theta. Secant theta is 1 over cos theta. We are going to multiply 1 over cos theta by what? What is tan squared theta? Remember, tan squared theta, tan is sine over cos. Tan is sine over cos. Like this. So tan squared theta is equals to sine squared theta over cos squared theta. So if it's 1 over sine, if it becomes 1 over sine, then it changes, we invert. Instead of on the denominator, then it will be cos squared. So now it will be cos squared theta, reverse, over sine squared theta, over sine squared theta, everything theta. So this is what we have done. Okay. Then from here, we continue. We want to know what are we going to do here. We know there are like terms which are going to cancel. We are going to have things which are going to cancel, which means cos cancel with that, which means we are going to be left with now. We are going to be left with now the integral of what is equals to 1 over 4 applied by the integral of what, which will be the integral of cos over sine, which means we are having a sine on the denominator. So tan is cos over sine. So which means one of the cos cancels. So which means we are left with cos over sine theta, cos over sine theta. Then multiplied by, again, 1 over sine theta, then d theta. Okay. The reason why we are going to do this, because there's an identity that we want to use. That's why we've manipulated into this. An identity that we want to use. That identity, we know that sine squared, sine squared, sine squared, sine squared is this one. That is the sine squared, which is there. So sine squared is nothing has changed. The cos is still there on the numerator. That is the cos still there on the numerator. Nothing has changed. So we know 1 over cos is cosec, and cos over sine is cot. So that's where we want to go. That is the direction where we want to go with cot and cosec. Because we know sine over cos, tan. So the inverse of tan, cot. All right. So now we'll say let's continue. Sorry. Interrupted again. I will share the screen again. So that is our integral for I. So in other words, I can be written like this. What we're integrating, that is I. I can be written like that. But now we want to go back to the information that we know. The information that we know of the triangle that we drew before, so that we can relate what we are able to do. Drew a triangle. We drew a triangle. It was like this. Right angle triangle. Then we said this was our theta. Then this is the root of x squared plus 4, and it always falls on the hypotenuse. Tan theta, remember it was x over 2, opposite over adjacent. Okay. That is tan theta. Cosec theta, you must know cosec theta is 1 over sin theta. So sin theta in our case, what is sin theta in our case? So to replace where we are given that, now we are going to replace to say, if I'm given cosec theta, then x is equal to negative 1 over 4. Okay. Cosec theta is 1 over sin theta. Must know sin theta plus c. So we are multiplying everything. So from our diagram, what is sin theta? Sin theta is x over root of what? Over root of x squared plus 4. So if it's sin theta is x over root of x squared plus 4, which means the reverse. It is opposite over hypotenuse. Now it is the hypotenuse over the opposite. So that's what we are going to do now. So which means 1 over sin theta. So which means it's negative 1 over 4 multiplied by. Now it's instead of opposite over adjacent over hypotenuse, now it will be hypotenuse over the opposite. So it will be root of x plus 4 over the hypotenuse over the opposite side, which is x plus c. So this is how we integrate using trigonometric substitution. So at the end, you must come back to replace your values back to x. You are given the expression in x. So now you change theta to x. And now we are changing the values from theta to x. We are changing now from theta to x. So you change the values from theta to x. So in terms of x, what is the value? What is the answer? So that is our answer in terms of x, because we were given the question in terms of x variable, which means we must also finalize our answer in terms of x. Since we are quiet, I don't know if you have understood. You are not responding, so let's continue. Let's continue. Let's continue. So now we are going to have another example, which we are going to do using trigonometric substitution as well. We are going to have another example. We are going to use using trigonometric substitution. All right. For example, let's go to this one. I is equals to x squared over integral of x squared over root of x squared minus 4 dx. Okay. So now you can see that the condition is now different from the first one. Condition is now different from the first one. This one is now subtracting, the first one was adding. The first one was adding. You can scroll upwards and find out that the first one was adding. We're adding. So now it's subtracting. There's a negative. Now there is a negative. So the way we treat what we let comes different. So which means when you see that it's a negative and it's x that is subtracting a constant, then you let x equals to 2 second theta. But if it's a constant subtracting the variables in the x, then it changes also to sine theta, a sine theta. So if it's a variable which is subtracting a constant, then you know it's going to be a, let x be a secant theta. So that is our condition that we are going to let you. So we are going to put our assumption, let a let x be equals to a secant theta. So to get what? What is it that you want to get? What is under the square root in order to get? Which means what is under the square root to get what? Get what is under the square root, which means to get this, what is under the square root. X squared minus 4. What you want to achieve? X squared minus 4. What is under the square root of x squared minus 4 is what is going to be equals to a tan theta. A tan theta. In other words, our a there you can see is 2. So it's going to be 2 tan theta. So already you have known the things that you are going to be substituting right away. So for a, for x, we are going to replace x with that. That is what we are going to replace x with. Then for this variable, which is the root under the root sign, we are going to replace it with this. Where there is that, we replace it. So this is what you must know by head before you go. So right, let's go from where we left in the substitution. Right, so we are here now, which means our x squared minus 4 is equal to 2 tan theta. But you also want to know, what is x by replacing a. So which means our x, come and say x is equals to 2 secant theta. Secant theta. That is our x. And then Secant theta, you know, is 1 over cos theta, which implies that we can draw now a triangle from in a position to draw triangle. Okay, because we know cos theta, which means our triangle secant theta is 1. So which means when we draw a triangle, it's going to be x over 2 equals to secant. What does that mean? What does that mean? What does that mean? It means that x over 2 equals to 1 over 1. Secant means cos. And over cos, it's the secant. And over cos. So what is cos theta in other words? In a triangle. Which means when you are saying x is equals to 2 secant theta. X is equals to 2 secant theta. So what is x squared? Because here we want to replace x squared. X squared is what we want to replace. So the denominator we know, dx, we are going to differentiate with respect to theta. So x squared, you must multiply. So this is how we drew the theta. We started by saying x is equal to 2 secant theta. Then we say x over 2 is equal to secant theta. What is secant theta equals to? 1 over cos theta. Then we cross multiply x cos theta will be equals to 2 over x. So this is what we will do. 2 over x, that is cos theta. 2 over x, that is cos theta. Then obviously the other side is what was under the squared side. So x squared let's continue. Let us back. Now we want to replace the values of theta into the values of x theta. Trigonometric substitution to solve. So for this one, want x squared. X squared will be equal to 4 secant squared theta. 4 secant squared theta. X squared which we are going to receive. What about dx theta? We are differentiating with respect to x. So dx theta must be in a position to differentiate 2 secant theta. When you differentiate secant theta, what are you going to get? Secant theta tan theta. So the answer will be 2 secant theta tan theta. Differentiate that. Then just make the theta subject of the formula dx, meaning dx equals to 2 secant theta and theta d theta. So where there's dx, we are going to substitute that. That is the substitution which I am talking about in terms of trigonometry. Substitution. Here we're saying x equals 2 seconds. X squared is 4 seconds. Dx is theta with differentiating with 2 tan theta tan theta. Then from there we say now this is our value in terms of dx. Our value in terms of this is our value in terms of x squared, in terms of theta and the x squared. So we are going to use this. And what is under the square root, we say we are going to use this one under the square root. So we are going to use this one and under the square root we put 2 tan theta. Then also we are going to get under x squared we put that. And also where there is dx, we are going to replace dx with that. So from now you'll be having some part marks before you finally integrate. Already having some marks just to for this setup. For dx, for x squared, just to tell us what is x equals to drawing a triangle. There are marks for that. Getting some marks. Then you wonder how many marks the question is. So the major thing is the left. So now it's a matter of us substituting and replacing the values of I. Yeah. Right. So our integral I, remember, is equals to the integral was the integral of x squared over square root of x squared minus 4 dx. That was our original equation. Then we substituted the values, everything. Now we say instead of writing that, we can write it now as integral where there is x squared. Where there is x squared, we are going to replace it with what? 4 second squared theta. So it will 4 second squared theta. That is the x squared. Then what is under the square root, we say that's what we are going to replace as 2 tan theta. 8 tan theta. So put 2. That is under the square root. 2 tan theta. Then dx in terms of d theta, dx in terms of d theta, we found 2 secant theta tan theta dt applied by 2 secant theta tan theta. Simple like that. Then don't forget then dt. So we are done with the setup of change of variables from the x to the theta. So it's a matter of now checking which one is common. You can see tan is common on the denominator, you factor out, you factor out. Tan is also common there on the numerator. Also they will cancel. Then you be left with the secant cube. So which means it will be making our lives a bit easy. So instead of having this one, now we come and say now it's equal to the integral of 4. So the 2 and the 2 they will cancel. Tan and tan they cancel. So you'll be left with 4 secant squared plus tan secant, 4 secant theta. So that will be our value which we want to integrate. Then you can take out the constant outside of the integral, which means it's equals to 4 multiplied by the integral of secant cubed theta. So that's where we are now. That's where we are. So here we are going to integrate by parts. But how are we going to integrate by parts? So we are going to use integration by parts for this part. Can't integrate it anymore using trigonometric substitution. So it will be by parts. So which means we are going to integrate by parts. Integrate by parts. That's what we want to do now. So while we're integrating by parts, we'll be recapping the integration by parts. So here we integrate. I'm going to integrate by parts. By parts. That's what we're doing. Integration by parts. So we'll split that into an even and odd function. Even and odd. So in other words, our I, which we want to integrate, our I is equals to 4 integral of secant cube theta dt. That is our I we want to integrate. So from there, we say split it into 2, and we say that the integral at the integral of secant cube theta dt, integral of secant cube theta is equals to the integral of secant squared theta, which is an even function. So we split it into even and odd. Secant squared theta multiplied by secant theta dt. So which means it will be by parts. So we are going to integrate these 2 by parts. So there are 2 different functions. U dv, which one is our u, which one is our v. So now we are going to say, given that situation, we are integrating by parts. No. Okay, continue. Right. So once we are going to integrate by parts, which means that we are going to look for what is our u, what is our dv, then we solve and substitute. That's what we are going to do. Let u equal something, let v equal something, etc. Right. Now let's continue. So from here, that situation, we are going to let what? We are going to say let u equals to secant theta. Let u equals to secant theta. Which one is our u here? The u is this one. So secant theta is our u. So it means this is the u, secant theta. And then the dv is dv. Secant square theta is theta. Comes with the dv. So that's what we are saying. So let your u be secant theta. So in other words, the integral of secant theta, secant squared theta dt, squared theta dt. So in other words, we are saying this is your u, this is your u, and the whole of this is what we call the dv. That's what we are saying. So by saying let u equals to secant part. So from there, our du is called secant theta. What is du? Repeat. So we differentiate du repeat. So here we say du respect to d theta. What is it? Equals to. So we know when we differentiate secant theta, it's secant theta times theta. Secant theta and theta. We differentiate that. Then it's a matter of just putting the u as the subject of the formula. Then we just say du is equals to secant theta, secant theta, and theta, dt is by part. So where there is du, you replace where there is du. Whenever you are going to see du, you replace du with this one. This expression is your du. Whenever you see du, you replace it. Where there is u, you are going to replace u. Now we go to the next one. We are given dv is secant squared theta dt. So we play in reverse here. So we are given dv is equal to secant squared theta dt, which means the original of that form, was what? You are given this. The original of that form was dv d theta. Differentiate v with respect to theta. We got secant squared it, reverse it. So that's what we did. When we differentiated dv with respect to theta, we got that. So what is the integral of that? So which means we are going to introduce the integral on both sides so that we can get the, what is it that we integrated to get. In other words, we are saying the integral of that will also be the integral of that, like that. In such a way that we are going to get v. Such a way that we are going to get v is the integral. So v, when we differentiate what, we get secant squared theta. We differentiate tan theta. But when we get secant squared, so that is our v. Then we highlight the v, going to be using, that is our v. So now we have v, dv, u, we are having u we have now, so we are checking the formula, what we are having. U, we now have our u, now we have our v, we have now du, so which means we can now integrate now by parts, by just replacing those values. Okay. So the integral, which one we are solving, the integral of secant cubed theta, uv, so we come and substitute uv. Come and substitute at the uv. It is the integral of what we are solving, secant cubed theta. U will be equals to the uv minus the integral v du. So this is what we are doing here. In other words, it was, you can call it the integral of secant theta, the integral of secant theta, secant squared theta theta is equals to 2v minus the integral of v du. That is the integration by part, because we are the ones that created the situation ourselves. Say this is our u. It is given the integral of u. This is the u. This is the dv. So that is the dv. That's where it's coming from. Okay. So that is the u. That is the dv. So if I given u dv to be uv minus integral of v du in such a way that now we are replacing the value. I'm just coming to say that I we are trying to solve, the I first, the integral uv will come and substitute the u plus secant theta, or u plus secant theta. So where there's u, we put secant theta plus secant theta multiplied by where there's v tan theta. So it will be v tan theta. Tan theta. Where there is minus, also put a negative. using the identity of tan. Use the identity of tan. Using the identity of tan. Share the screen. Using the identity of tan. What does the identity of tan tells us, and why are we introducing? We want to separate this two so that we can integrate it differently. Like this, we can't integrate. So the idea of introducing tan is we want to separate because tan is a negative. So we use that identity of tan to separate them so that we can integrate. So let's use the identity of tan. The identity of tan tells us that tan squared theta is equals to secant squared theta minus 1. So that is the identity for tan. That is the identity for tan. That is what we are going to use there. So we use the identity for tan. So we replace this identity for tan. So we are going to use that identity for tan. We are going to use it. Okay. So from there, we conclude that. Go on further now to replace that identity for tan. What are we going to see? Right, let's continue. Integration by trig substitution. So we are having that. So now we can see that there are common things on the left and on the right. So we are having two things which are common on the left, are common on the right. So what is it that is common on the left? Let's underline it. So it's negative, common here, that is common. So if we move that to the left hand side, move this to the left hand side, it's going to give us what? What is it going to give us? It's going to give us 2i. 2 of the integral of secant cube theta is equals to secant theta applied by tan theta plus secant theta tan theta. That's it. All right. So that's where we are. Then from there, say this one was not having secant squared. One is secant theta. Secant theta. Move that. Not having secant squared, it's secant theta. So let's remove that secant theta. Remove that secant theta. Instead, secant theta. Okay. So it's secant theta, not secant squared theta. So from there, we are going to say 2 integrate secant theta. What is it that we differentiated? So no is supposed to be the ln of secant theta tan theta. So this we must know that. The integral of secant 2 multiplied by secant cube theta, the cube theta equals to secant theta multiplied by tan theta multiplied by tan theta plus this we must memorize. This we must memorize by it. Must know that the integral of secant theta is the ln of secant theta plus tan. So this we must know by it. That is the ln of secant theta plus tan. So which means the answer then that's the ln of absolute secant theta plus tan theta. Know that absolute secant theta plus tan. So our integral was for us to find what is secant theta equals to. So we are not interested in true secant theta, but only secant theta. So which means secant theta, the integral of secant theta, integral secant cube theta that we are looking for, integral of secant cube theta is equal to half. It will be half secant theta and theta plus half of ln absolute of secant theta plus tan theta. Half of secant theta plus tan theta. So that is where we are, plus C. Plus C. So that you must know the integral of ln of secant theta must know it by head. Head by head, the ln of secant theta. Head by head. This is the ln. Must know that. Then let's continue from there. So now we know the integral of that. So our question was I is for the integral of that. So then we are going to multiply by 4. So remember our I, which we are solving, our I is equals to 4 multiplied by the integral of secant cube theta. So now when we multiply by 4, what is it going to be equal? Everything by 4, which means it's going to be equals to everything by 4 is going to be 2 secant theta tan theta plus 2 absolute secant theta plus tan theta absolute plus C. Plus C. That is the integral. And don't forget to convert this back to x. So for today we are going to end here, but we are supposed to convert I into x, which means this theta, we are supposed to put it back again into x variables, where you'll be using the triangle. So that's where we are going to catch up from tomorrow, where we'll be using the triangle. So for today, let's just recap what we just done again. So this was the second one, when we're solving for the integral of I. Integral of the second part. Let's just recap. We started by here. So if you are given where they are subtracting x squared minus 4, what do you do? Let. Which means you are going to let a x equals to a secant x. Let a equals to what they are subtracting. After that, x, find the value of a. A is 2, so which means you are going to use a tan theta in order for you to get what? A is equals to 2 secant theta to get a tan theta, which is 2 tan theta. Then from there, what did we do? We drew our triangle by using the trig ratios that secant theta is 1 over cos theta. Make cos theta substitute the formula, so we can draw the triangle. And obviously the other side which is missing is the square root side, under the square root. Okay. Then from there, we found our x squared, was in the expression. We made dx d theta, found dx d theta, and then we replaced dx as substitute the formula. Then from there, now we substitute where there's x squared, we put 4 secant squared theta. Where there's dx, we put 2 secant theta tan theta tan theta. Where there was the root of x squared minus 4, we put 2 tan theta. Then we saw that the tan at the bottom of the numerator is cancelling with the 2 tan on top. Then we are left with 4 secant cubed theta. Then we took out the constant part of the integral, comes 4 secant cubed theta. We used the integration by parts. What did we do? We let our u was secant theta. And then our dv is secant squared theta dθ. What does integration by parts tell us? Integral of u dv is equals to uv minus integral of v dv. So the u is equal to secant theta. What about du to theta? Secant theta and theta. Using your integration, your differentiation techniques. Let dv started with the formula is dv is equals to secant theta tan theta. What about dv? dv is secant squared theta d theta, meaning that dv d theta was secant squared theta. What did we differentiate with respect to theta? Differentiated tan theta, the secant theta. dv d theta. That's what happened. Then from there, we are replacing the values for u, v, integral of v, u, du. Where there is u, we put secant theta. Where there is v, we put tan theta minus integral of tan theta du, which is secant theta tan theta. Then from there, we introduce the identity to separate the terms. Using the identity, tan squared theta is equal to secant squared theta minus 1 to separate the terms. Then from there, once we separated the term using identity so that it's possible for us to integrate, our I is now secant theta tan theta minus integral of where there is tan squared theta, we replace by secant squared theta minus 1. Therefore, from there, multiply by secant theta, which is outside the bracket. Repeat. I is equal to secant theta tan theta minus the integral. So we expand the bracket. Secant theta, squared theta multiplied by secant theta, secant squared. Cubed theta d theta. Negative times negative, positive. Secant theta d theta. And from there, we know our I, original I was integral of secant cubed theta. But however, we are noticing that there's another integral that is similar to what we are looking for. So we put it on the left-hand side. So instead of one of those, now there are 2. Since negative goes that side, come plus 2 of those. That's where the 2 is coming in. Is equals to secant theta tan theta plus integral of secant theta d. So 2 of that. So you must know the integral of secant theta is just being secant theta plus tan. Then from there we integrate, we know the answer. Now we knew that the original of I was being multiplied by 4. So we multiply the coefficients So I was saying here the integral of secant theta is ln of secant theta plus tan theta. This one must know by heart. Or this one by heart. Must know it by heart. Yeah, must know it by heart. Memorizing it must memorize that one. So once we have found that, we replaced, and then we knew our I. Our I was 4 multiplied by secant squared theta. So which means you apply the constant as well by 4 in order for us to get the I. So after this, you convert now to x. So which means you have to convert theta to x. So that's what is left now. You have to convert the theta back x. That is what is left. So you convert the theta back. And convert the theta back to x. Like using the triangle. It's using the triangle. Get the theta back to x. So that is the last thing. So we'll stop here for today. If you are stuck in converting to theta to x, then we'll continue from there tomorrow. Try to have a session within the day before you write so that you are able to catch up. So we'll end here for now. We'll end here for now. So this is what we have done today. So we are going to forget the identity as well. That